What is the area of the yellow circle? Label points A, B, C, D, and E. Join line A, B, line AD, and line C, E. Let angle B, A, D equals beta. This implies that angle C, E, D equals beta, which equals angle B, A, D. It is because angles in the same segment are equal. It follows that line C, be divided by line B, E equals line B, D divided by line A, B, which equals to tan beta. It signify that 12 divided by 9 equals 5 divided by line AB. Cross multiply and we have that 12 times line A, B equals 9 times 5, which equals to 45. Divided the equation by 12 and we have that line A, B equals 45 divided by 12, which equals to 15 divided by 4 after simplification of values. Use the formula. For times the square of R equals the sum of the square of A, the square of B, the square of C, and the square of D. Here, A equals 15 divided by 4, B equals 5, C equals 12, and D equals 9. Substitute the values in the formula, and we have that. For times the square of R equals the sum of the square of 15 divided by 4, the square of 5, the square of 12, and the square of 9. Divided the equation by 4, and we have the equation for the square of R as shown on the screen. Simplify and we have that the square of R equals 4,225 divided by 64. Take the square root of the equation and we have that R equals the square root of 4,225 divided by 64, which equals 65 divided by 8. Hence, R equals to 65 divided by 8 in units. Mark the diameter of the circle and locate the center, O. Label points G, J, and K. It implies that line D, J equals half of line D, E, which equals to 7. After substitution and simplification of values, join line D, O equals R. By Pythagoras' theorem, the square of line J, O equals the square of line D, O minus the square of line D, J. Substitute values and we have that the square of line J, O equals the square of 65 divided by 8 minus the square of 7, which equals 1089 divided by 64. Take the square root of the equation. This implies that line J, O equals the square root of 1089 divided by 64, which equals to 33 divided by 8. Let line G, J equals the product of 2 and R, where R is the radius of the yellow circle. It signify that the sum of 2 times R and line J, O equals line D, O which equals to R. The result is equals to 65 divided by 8. It follows that 2 times R equals 65 divided by 8 minus line J, O which equals to 4. After substitution and simplification of values. It implies that 2 times r equals to 4. Divide the equation by 2 and we have that r equals half of 4, which equals to 2. Therefore, the area of the yellow circle equals the product of pi and the square of r, which equals to 4 times pi in square units.
Find the circumference of the inscribed green circle. Label points J, H, G, C, B, D, E, and F. Since J, H, G, C is a square, this implies that line G, H equals to line C, G. It is because the side lengths of a square are equal. It means that CE equals to CG minus EG, which equals to 1 unit. Locate the center O of the circle. Join line B, O and line C, D, each of which equals to the radius, R of the circle. It implies that DE equals CE minus CD, which equals 1 minus R. Also, join E, O, which is an angular bisector of angle DEF. It implies that now, from triangle EGH and let angle GEH equals beta. It signify that angle DEO equals 180 degrees minus half of beta, which equals to 90 degrees minus half of beta. Consider triangle DOE. By Pythagoras' theorem, the square of EO equals the sum of the square of DO and the square of DE, which equals to the square of R and the square of 1 minus R. Find the square root of the equation and we have that EO equals the square root of square of R plus the square of 1 minus R. By trigonometric identity, DO divided by EO equals sine 90 degrees minus half beta, which equals to R divided by the square root of the square of R plus the square of 1 minus R. We call it equation 2. But sine 90 degrees minus half of beta equals cosine half of beta. Substituted in equation 2, it implies that R divided by the square root of the square of R plus the square of 1 minus R equals cosine half of beta. We call it equation X. From triangle HEG. By Pythagoras' theorem, the square of HE equals the sum of the square of GE and the square of HG. Substitute values. We have that the square of HE equals the sum of the square of 4 and the square of 3, which equals 225. Take the square root of the equation and we have that HE equals the square root of 25, which equals to 5. Thus, cosine beta equals GE divided by HE, which equals to 3 divided by 5. By trigonometric identity, cosine beta equals the product of 2 and cosine square half of beta minus 1. Substitute value of beta. This implies that the product of 2 and cosine square half of beta minus 1 equals 3 divided by 5. It implies that the product of 2 and cosine square half of beta equals the sum of 3 divided by 5 and 1, which equals to 8 divided by 5. Divide the equation by 2. We have that cosine square half of beta equals 4 divided by 5. Take the square root of the equation. Thus, cosine half of beta equals the square root of 4 divided by 5, which equals to 2 divided by the square root of 5. Substitute in equation x. It implies that r divided by the square root of the sum of the square of r and the square of 1 minus the square of r, which equals to 2 divided by the square root of 5. Square the equation to obtain a new equation as shown on the screen. Cross multiply. Simplify the equation further, and we have that the sum of 4 times the square of r and 4 minus 8 times r plus 4 times the square of r equals to the sum of 8 times the square of r and 4 minus 8 times r. It signify that 5 times the square of r equals 8 times the square of r plus 4 minus 8 times r. Factorize and simplify. We have that the product of r minus 2 and 3 times r minus 2 equals to 0. Thus, r minus 2 equals 0, or 3 times r minus 2 equals 0. It implies that r equals to 2, or r equals to 2 divided by 3. Since the length of line BO equals to r, and r is less than the length of line CE, which equals 1 unit, it implies that r is not equals 2 units. Thus, r equals 2 divided by 3 units. Therefore, the circumference of the circle equals the product of 2 and pi times r, which equals to the product of 4 and pi, all divided by 3. In units. After substitution and simplification of values.
Required to find the length of the red line, label x and the area of the circle in terms of pi. Make some constructions as shown. Add 2 congruent squares in upper side and 1 congruent square to the right. Let y be the length of red line left after placing the equal squares at both ends. Since the area of the similar square, A equals 1 square unit and L, let Z equals the length of the square. Then, Z equals the square root of 1, which is equals to 1. The side length of the square is 1 unit. This implies that the ratio of length of line B, m to the length of line D, m equals to the ratio of length of line C, m to the length of line H, m which is equals to tan alpha. Side angle side is a property of similar triangles. Thus, the ratio of the sum of 1 and y to 3 equals to the ratio of 1 to the sum of 2 and y. Cross multiply and solve for y. Expand brackets and collect like terms. We have that the sum of 2 and y and 2 times y and the square of y equals 3. Simplify and arrange terms in one side of the equation, and we have that y squared plus 3 times y negative 1 equals to 0. Use general quadratic equation formula to solve for y, and we have that y equals negative 3 plus or minus the square root of 3 square plus 4 times 1 all divided by 2 times 1. Simplify and we have that y equals to negative 3 plus or minus the square root of 13 all divided by 2. Take the positive result of y as length cannot have a negative value. That is, y equals to negative 3 plus the square root of 13 all divided by 2. The length of the line C, D equals the sum of 2 times y and 3 which is equals to x. Substitute value and simplify. We have that the length of the line C, D, equals the square root of 13 units. Therefore, the length of the red line equals square root of 13 units. Using a rule of 4 points inside a circle, that is, the product of 4 and the square of r equals the sum of the square of line H, M, the square of line B, M, the square of line C, M and the square of line D, M. Substitute values and simplify to have that the product of 4 and the square of r equals 17. Divide the equation by 4. This implies that the square of r equals to 17 divided by 4. Find the square root of the equation, and we have that r equals the square root of 17 divided by 2 units. Area of a circle equals to product of pi and the square of r. This implies that the area of the required circle, A equals 17 times pi all divided by 4 square units. Therefore the area of the circle equals 17 times pi all divided by 4 square units.
What is the radius and the area of the given circle? Label A, D and C and join line A, D, line A, C and line C, D, respectively, to form a right triangle A, C, D. Label angle alpha. Since area of the inscribed square equals 16 square units, it is given, and let x be the side length of the square. Then, the square of x equals 16. Take the square root of the equation and we have that x equals to 4 units. We are to find angle alpha in triangle ACD. By Pythagoras' theorem, its diagonal length, d equals to 4 times the square root of 2. This implies that line AD equals to 10 times the square root of 2 after substituting values and simplification. Also, line C, d equals to 6 times the square root of 2. By trigonometric identity, the ratio of line A, d to line C, d equals to 10 alpha, which is equals to 5 divided by 3 after simplification of substituted values. By Pythagoras' theorem, the square of line A, C equals to the sum of the square of line C, D and the square of A, D. Substituting values, we have that the square of line A, C equals to 34. Find the square root of the equation and we have that the length of line A, C equals to the square root of 34. By trigonometric identity, sine alpha equals to the ratio of line A, D to line A, C, which is equals to 5 divided by the square root of 34. Cosine alpha equals to the ratio of line C, D to line A, C, which is equals to 3 divided by the square root of 34. Label B and G and join line AB. We need to find line A, B before we can solve for the radius r of the circle. Consider triangle AGB. Line AG equals to 8 times the square root of 2 and line B, G equals to 8. And angle AGB equals to the sum of 90 degrees and 45 degrees, which is equals to 135 degrees. Using cosine rule for the equation of the square of line A, B is shown on the screen. Substitute values, simplifying, and we have that the square of line A, B equals the sum of 128, 64, and the product of 128, the square root of 2 and the square root of 1 divided by 2. Simplify and we have that the square of line A, B equals to 320. We call it equation 1. Choose and label center O before the line A, B. Join line A, O, which is equals to line B, O. These lines are equal to the radius r of the circle respectively. Now consider irregular constructed quadrilateral. Angle AC, B equals the sum of alpha and 45 degrees. Thus, Refelk's angle A, OB equals to 2 times the sum of alpha and 45 degrees. And from triangle A, O, B and its angle, which is equals to 270 degrees minus 2 times alpha. This is because the sum of angles at a point equals to 360 degrees. Using cosine rule, the square of line A, B equals to 2 times the square of line A, O times 1 minus cosine 270 degrees minus 2 times alpha. By substitute values from equation 1 and line A, O equals to R, the radius of the circle, we obtained equation as shown on the screen. Using trigonometric identity, cosine 270 degrees minus 2 times alpha equals to negative 2 times sine alpha cosine alpha after simplification. This is because cosine 270 degrees equals to 0 and sine 270 degrees equals to negative 1. Recall that we obtained sine alpha equals to 5 divided by the square root of 34 and cosine alpha equals to 3 divided by the square root of 34, and we have that cosine 270 degrees minus 2 times alpha equals to negative 30 divided by 34 after substitution of values and simplification. Substitute in the equation as shown on the screen and we have that 320 equals to 2 times the square of R times 64 divided by 34. Cross multiply and make the square of R the subject of the formula or solve for the square of. We have that for question I, the square of R equals to 85 units after substituting values and simplifying terms. Find the square root of the equation. We have that R equals the square root of 85. Therefore, radius R equals the square root of 85 units. For question 2, area of a circle equals to pi times the square of R. The required area of the circle equals to 85 times pi unit square. Therefore, circle area required equals 85 times pi unit square.